Okay, guys, so I just wanted to go over some of the homework from last night because I figure there are probably questions and I'd like to be able to give you the answers. So let's start with number 7. Number 7 from page 626 or 627. It says that you have two machines. Machine A, which produces 60% of the ball bearings manufactured by a factory, and machine B produces the rest. 5% of machine A's bearings fail to have the required precision, and 2% of machine B's bearings fail. And they want us to incorporate this into a tree diagram. So basically, there are two machines, A and B, and there's essentially some kind of test, and the parts being produced by these two machines could pass or could fail the test. And it sounds like the machines have different accuracy, different precision, like maybe machine A's parts are more or less likely to pass the test than machine B's parts. So the first split in the tree diagram is whether the parts are produced by machine A or machine B. And the second split is whether the parts, the bearings, pass or fail the test. So I'm going to label the branches as P and F for pass and fail. And now let's try and let's get some numbers in here. So the very first figure you see in the problem is the 60% number. It says 60%, machine A produces 60% of the parts. So, that goes right here. That's just the probability that a given part is produced by machine A. And then, of course, that means that 40% of the parts are produced by machine B. So that's got to be 0.40. We're also told that 5% of machine A's bearings fail. Okay. So assuming that your part was produced by machine A, it's got a 5% chance to fail. And the other thing they say finally is 2% of machine B's parts fail. So that would be this guy right here. This has to be 0.02. And now we can compute the rest of the numbers in the diagram. These two figures have to add up to 1. So this must be 0.95. These two have to add up to 1. So this must be 0.98. And now we have to compute the end branch probabilities, which are obtained by multiplying along the branches. So this number here, this end branch that goes right here is going to be 0.60 times 0.95, which is 0.57. And then the next one's going to be 0.60 times 0.5 or 0.05. So that's 0.03. Then 0.4 times 0.98. That's 0.392. And finally, this branch will be 0.4 times 0.02, which is 0.008. And that is the completed tree diagram. If you want to check that you've done everything correctly, you can verify that these 4 end branch probabilities add up to 1, and they do. So part A is to just set up the tree diagram. Part B is to, well, 7B, they ask you the question, what percent of the bearings, that is the parts, what percent of the parts fail? Okay, what percentage of the parts fail? That's basically just what's the probability of failure. I want to be careful here. I'm using P to mean probability here, but over here I'm using it to mean pass. I hope that's not confusing. So this is the probability of failure. Well, the thing is, failure is an outcome which is associated with more than one branch in the tree diagram, this one and this one, which means to find it, we need to add together all the end branch probabilities associated with that event. So that would be the 0.03 plus the 0.008. Okay, so whatever that is, that'll be the probability of failure. 7C, they say if a bearing is inspected and it fails to have the required precision, what is the probability that it was produced by machine A? In other words, given that a part failed, what's the probability it was produced by machine A? That's, in other words, the probability of A given the fact that it failed, okay? The probability that it was made by machine A given the fact that it failed. Well, that of course is a backwards conditional problem, right? The tree diagram as it's set up is sort of set up so that, passing and failing depends upon which machine, but here the conditionality is reversed, which means you need to use your conditional probability formula. So that's the probability of, the probability of one thing given another is the probability of both things divided by the probability of the given thing. Well, the numerator here, the probability of A and F, that's an end branch probability. That's this guy right here. That's the 0.03. Probability of F, we actually already looked at that in the previous problem. That's 0.03 plus 0.008. So whatever that turns out to be will be the answer. Again, remember that you cannot, you can't cancel the 2.03s, right? So don't make that mistake. And yeah, let's see. Oh, I could go over 11, but I suppose that it's pretty similar. Let's go over 15. I think I'll do 15. And then we'll stop there. And hopefully that will give you a good sense of how to do these tree diagram problems. So 15 says, suppose you have two pairs of dice. One pair is fair, but each die of the other pair is weighted so that a 6 comes up with probability 1/4 instead of the usual 1/6. If you randomly choose one pair of dice, roll them, and obtain 2 6s, what's the probability that you rolled the weighted dice? Okay, so basically there are the first split is whether you choose the fair pair of dice, or I don't know what I want to call the other pair. The weighted pair, right? So I'll abbreviate this with an F and this with a W. So the first split is which pair of dice you choose. Could be the fair one or could be the weighted one. And then the second split is whether you get 2 6s or don't, right? That's kind of the other split. So you could get 2 6s or not 2 6s, like anything else, like say 1 6 and a 5 or a 2 and a 3, right? Remember, you're rolling 2 dice here. So, and then again, this split, you could have 2 6s or not any of the other possibilities. So let's try and get some numbers on here. First of all, you're choosing randomly one of the pair of dice. There's just 2 pairs. There's the fair pair and the weighted pair. So the probability of choosing either one of those is just 50%, so 0.5 on both of those. If you choose the fair pair, then the probability of obtaining 2 6s is, well, if you think about it, there are really 36 possible outcomes if you roll 2 dice, like 6 choices for the first dice, or for the first die, and then 6 choices for the next. So 36 total choices. And getting 2 6s, there's only one way of that happening. You just get 6 both times. So the probability of getting 2 6s, at least with the regular fair dice, is 1 out of 36. Or you can also think of it as like, oh, I have a 1 out of 6 chance of getting a 6 on the first dice, and then a 1 out of 6 chance of getting a 6 on the second dice. So the product gives you 1 out of 36. That means that this probability here, of course, has to be 35 out of 36 because these 2 guys have to add up to 1. Down here with the weighted dice, though, we're told that with the weighted dice, you have a higher chance of getting a 6. Instead of it being 1 out of 6, you have a 1 out of 4 chance of getting a 6. So the probability of getting 2 6s would be 1 out of 4 times 1 out of 4, which would be 1 out of 16. And then the probability of getting anything else, well, you know, these two guys have to add up to 1. So this would be 15 out of 16. Then you can get the end branch probabilities pretty easy. 0.5 is just a half. So if you multiply these two guys, you get 1 out of 72. Multiply these two guys, it's 35 out of 72. Multiply these two guys, it's 1 out of 32. Multiply these two guys, it's 15. Oops, sorry, I wrote 32. I did not mean 32. Or no, I did mean 1 out of 32. My bad. 1 out of 32 is correct. 1/2 times 1/16 is 1 over 32. And then this guy here, 1/2 times 15 out of 16 is 15 out of 32. If you add all of these up, they should add up to 1. And so that's the entire tree diagram. Now, to answer the question, they say, you know, if you randomly choose one pair of dice, roll them and obtain 2 6s, what's the probability that you rolled the weighted dice? So it's really saying, given the fact that you got 2 6s, what's the probability that you had the weighted pair? So the given fact is that you got 2 6s, okay? And you want to know, given that fact, what's the probability that you got the weighted dice? So that's a backwards conditional problem. You need to do the formula. That's the probability that it's weighted and that you got 2 6s divided by the probability that you got 2 6s. That's going to be very similar to these other problems. Weighted and 2 6s. That's going to be this guy right here, the 1 out of 32. Probability of 2 6s, that outcome is associated with more than one branch. So you're going to have to add all of the end branch probabilities associated with it. So that's going to be this plus this. So that would be 1 out of 72 plus 1 out of 32. And whatever that number is the answer. So hopefully that gives you a little bit more clarity on some of these tree diagram problems. We'll practice them more going forward as well.